So if you're joining us online, we are just finishing up with some brainstorming about how to implement user management inside of Node. Again, so I've just put up the material for this class, so feel free to pull this up and follow along now. You can go to our OKCoders at github.com. It's lesson 19, Node users class. And again, I linked to previous lesson material for the template, but really what we're going to be discussing today is in users.md, managing users. So, okay, before we get into that, let me ask you about so I mean, listening to you guys, so your experience was, a lot of it is, well, it needs to do this, but then if it does that, we need to do this. But if it does that, then we need to do this. So there's this almost like explosion of issues that you have to take care of as soon as you start diving into the details. Like, it's easy to start mocking up the site. It's not so easy, to make it good. So I'm not saying that design is easy, but it's like, okay, it's going to be a form with some buttons on it. Now what happens? Well, they press the submit button. Okay, now what happens? They're signing up. And like diving into those details, you realize that there's just tons and tons and tons of conditions that you have to check for and care that you have to take to make sure that you're implementing users correctly. I think implementing users is one of the trickiest things, and you have to get it right, because if you don't, people will break into your site and they will steal information from you. And if you are storing sensitive information, like you have an e-commerce site and you're keeping people's credit card numbers, which hopefully you're not, you're having maybe a third party do that for you, but any other sensitive information, social security numbers, addresses, even an email address can be considered sensitive. How do you prevent people from getting to that? You can't screw this up, really. It's a very, it requires a lot of attention to detail. So let's go back to that one question that I was just asking, which was, what does user sign-in look like? What do we need to do to support letting a user sign into our page? The page itself, what does that look like? So what did you guys decide we needed to have on our sign-up page?
Email.
Okay. So we're asking for their email. Okay.
The name.
Okay, name.
And password. It's really kind of like the bare minimum, I guess.
Okay.
You might want to check for like their age, with birth date or something like that.
What kind of site are you making?
Yeah, yeah. So age, but you should. I mean, I know Aaron has probably encountered this all the time. Are you 13 or older? Like anytime that's like the question that people always have because of recent U.S. laws, like within the last 2 years or something, that changed what sites have to, how sites have to control access for people 13 and younger. Okay, so depending on what kind of content you have, maybe age. We're not going to include it in ours because it's just blog posts. Password.
Submit and create.
Submit.
Or create.
What do you mean by create?
You have to do both.
Why would you need to submit and create?
Well, what if they didn't exist in the database?
Okay.
Kick out a message and say, create account.
Okay, so who do you think, so let me ask this, who do you think is going to this page?
The user.
The user, or it sounds like you think the administrator is going to this page.
No.
No? So if just the user is going to the page, yeah.
I think what she's trying to differentiate is between like a user who's already on your site and a new user.
Okay.
Right.
Okay. So that is good. So that does come up as an issue. So.
Or if you want to change it, if you're a user.
Or if you want to change it. So let's.
Well, sign up and login would be.
But we're not talking about. So this is a very thank you, Mayo, for clarifying that. This is a super good distinction. I'm going to the sign up page, assuming I am not currently signed into the site. If I am signed into the site and I try to go to the sign up page, what happens?
You should get a message.
Or so
default page.
So we're going to do asterisks or not signed in. So, but that is exactly the kind of attention to detail that you quickly realize is necessary to account for as soon as you start doing anything with users. What happens if I try to, a flip side of that is, what happens if I try to go to the logout page, but I'm not signed in? Should I even see the logout page? But it may not matter because somebody could just type in logout, right, in the URL, and now they're going to the logout page, but they're not signed in. So what would you do? I mean, right? So there's not necessarily a correct answer, although often there are best practices. So if you go to a logout page and you're not signed in, normally it would redirect you to the sign-in page and say you're not signed in, right? If you go to the sign-up page and you're already signed in, you might have a link at the button like Google does, or a link at the bottom like Google does, that's smaller than submit but says already signed in and want to sign in as someone else, sign out. Serving two different functions, they would click sign out, it would sign them out and then send them back to the sign up page, right? But that means that this button needs to kind of know where it is currently at so that they can redirect them back to sign up. So this is not just the same as logging out, which might normally redirect them back to the home page. So very subtle issues. So that's a good one. Let me just asterisk that and say, okay, we're not signed in for now. Although that is one of the things to think about. Do we want to check their password twice? Do we want to make them re-enter their password?
Yeah,
So
probably a good idea. Otherwise, you're going to get a lot of password resets.
I think you want to authenticate the email.
okay, so let's pause there. So do we need to gather any other information? Think this is good enough?
Pretty much bare minimum.
Pretty much bare minimum. We can make this even less required. So go to,
Or remove the name.
and not just only, right? So go to Heroku.com. So as we did, and you got, if you're not, and make sure you're signed out. I love the way Heroku does this. I think it's an excellent example. This is a problem of design and an issue with dealing with forms on the internet. People hate forms. So like, I'm going to go to Heroku and I'm going to go to sign up. Just wants my email address. That is incredible, right? Give me your email address and I will sign you up. And so rather than like throwing a whole bunch of form fields at you and forcing your user to enter in a lot of information immediately, you lead them in steps through the process, or just simply require as little as possible. And now I think that's pretty bare minimum. If you do that, the next step is what password, what's your password, right? But that's all. I think that's all they ask. And they might even send you an email, and then you click on that email. So yes, there's an email verification step, and they actually do that before you've completed the whole sign-up form, right?
Well, that just verifies that it's an
actual email, which is not the same as checking that it's a valid email. That is different. A valid email is phil@phildow.net. It's got the @ symbol, it's got the .net, it's got three parts. A verified email address is one where somehow you sent an email to that email address, and that person then clicked on that link in the email address that then goes back to your site and somehow knows that it's waiting for verification from that person, right? But let's get into those details in just a second. Looking at this form, but again, so this is exactly the point, right? There's like so many moving parts to getting this right, and they're worth thinking about and understanding why it's necessary. And it has to do with just security, like you're controlling access to information to your site. You've got to do that right. And so what you're going to commonly see is that an email address is required. No name is required. Don't give me your name. I don't care what your name is. I don't even want you to pick a username because you're going to sign into my site with your email address, and that's it. And then maybe in your profile page somewhere, you can choose the name that appears when other people see you when you're logged in or whatever, right? But I don't really need that from you now. And what that means is that when you sign in, you're going to sign in with your email address because it's the only piece of information I've got about you right now. So, and then we do want them to give us their password, obviously. Or we could do it 2 steps like Heroku, but again, I think that's pretty fair. So we'll just say password. And then you're like, well, yeah, let's add re-enter because we don't want people resetting their password. Why not? Screw it. If they forget their password, they can click a button that says reset their password. And
That's
so
their problem.
that's their problem. And so like you see this on a lot of sites now. Nobody is asking you to verify their passwords anymore. It's like if you only have 2 fields, adding, oh yeah, that's no big deal, just another field. That's 50% more information, actually, when you're only requiring 2 bits of information right now, which seems like a ridiculous way to think about it, but it is. You're asking for exactly 50% more information. So screw it, get rid of it. If they forget their password, provide them a link for resetting their password, right? And so now you've like minimized the amount of information that they need to sign into your site, and you've got enough to let them to create a user and let them sign in. So good enough for now, right? Okay. Now, what actually happens? Well, first of all, what page are they visiting to see this form? What's the URL?
Index.
Index on what? Gotta be,
HTML.
probably not. That's your home page, right?
On this one, it's just www.roku.com.
Is it sign up? No.
Oh, I didn't do sign up. I'm sorry.
But that's a good point. How do they get to this page? We're not even to this page yet. Somehow they have to get to this page. So there needs to be a link on your page somewhere for people to sign up, right? Often that goes up in the top right corner. Some people know to look for it there now. So there's like a sign up button. Or somewhere in your copy on the front page, if you're trying to push users logging in, you make sure to include a link to the page, right? So let's say they clicked on sign up, and now what is the URL that clicking on this sign up takes them to? So it's, whatever your website is, HTTP, blah, 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 blah.
Login.
We got login, could be one. Okay.
Sign up.
Sign up. Well, so this is not logging in. That is not one. This is not one.
Sorry, yeah, sign.
Right, sign up.
Yep.
So sign up. Okay. Very common to see that. I'm implementing it as users sign up, although I'm not even sure I like that, but it's going to be something like that. Users new, sure. Right? If we treat it like a user's resource, in a sense, this is the new form for creating a new user, right? And that's more RESTful than the others. So, but in a sense, often users are not quite treated the same way that other resources on your site are treated. They're a little bit different. They're usually not RESTfully accessed either. Although usually you can go to a person's site, users can't edit other people, right? Can't just go randomly create lots of people. So often they're a little bit different, but that's still an option. Okay, so I'm going to put users sign up. But all of those are good options. Now, what happens when they click submit? So this is a GET request. What happens when they click submit? Where's it going?
It has to.
It's going to post. Where's it going to post to?
Users table.
Well, I won't post to the table itself. We got to get through our route somewhere, right?
So it has to, first of all, verify that the information is unique. So they know.
Well, yes, but that means we need a route for handling all that. That's all going to go in our route handler. What's the URL that route handler is associated with? Choose a URL.
New.
Could be users new.
Or just users.
Or just users. Or I'm just duplicating. Sign up, right? Because get and post are two different kinds of requests, so I can reuse the same URL for that. You know, in a sense, this form is posting to itself, in a sense, right? So I think that's one way to do it. You could just post to users. That would be the resourceful way to do it. I'm going to post to users sign up. That means that the questions that we're addressing here so far are: what does the page look like? What kind of information do I need to get from the user? How does the user get to that page? Like, these are the kinds of questions we need to be asking ourselves almost any time we want to add any new feature to our site. And then finally, what are the routes? What are the URLs that they're going to deal with, right? And so we've got post users, get user sign up, and post user sign up. So now, like Kevin is saying, now we are inside of this route. You know, it's going to look like router.post users sign up, right? And then it's going to have our function callback with request and response object, right? And we'll see this in a second here. Now I'm in my function. Let's not actually write it out as JavaScript. Let's talk about the algorithm. Let's talk about the process. At this point, what do I need to do? So the user just hit that submit button. What's the first thing I should do?
Authenticate.
So what does that mean?
It's, well, you have to check it with the database.
Okay, so how do we do that?
Emails. So how do we do that in terms of code
sure.
or what?
So what does that mean? So we know we want to. So let's
Should we check to see if it exists first?
Okay, so that's so good. So we can query our database for a user with this email address, right? And so in Mongo, That means we're going to have some kind of user object, which we haven't created yet. So we need to create a user object and figure out what goes on that. But Mongo provides a method, find1, which is like find by ID or find. We give it a query object. My query object will be email is what? What's my email? How do I know what my email is from this post? Actual code in JavaScript this time?
User.
Nope.
I'm sorry.
It's coming in off the request object.
Oh,
Dot, not params. Params are what's in the URL. It's coming in the form, which is encoded in the body, the post body. So request.body dot what? Email. Why?
That's what you labeled that.
Because that's so in my HTML I say name equals email, name equals password, right? Details that you got to get right. Yeah. Otherwise your form has no idea what to call these things. Great. Search for this. That's got a callback. It's going to give me an error and possibly a user if it finds one. Okay? Now I'm in there. What do I need to check for?
If it exists.
So first, so yes, if it exists. So that means if we could say not user. That would be the user doesn't exist. Actually, let's actually do it your way. If user. So if user, what's the first thing that we should check for? Let's make that the second thing we check for.
Error.
Error. Let's just check for error first. If error. So it's just something completely blew up, right? Some bad input or the database is down or something went terribly wrong. We got an error. We render our 500 page or do whatever. Okay, good. Why do we check to see if a user already exists with this email address?
Because no duplicated
just blurt it out.
users are allowed.
No duplicated errors, or no duplicated users. So this is considered an error as well. So what should we do? We found a duplicate user. Let's go. Let's break the options to reset their password. That's assuming that the user typed their email in correctly, right? So what do I really want to do here? Before we give them that option, like how am I even going to get them to the page that gives them the option to do that?
You're just checking the database to make sure that
Okay.
this is not a current user.
Yeah, but we've done that. So now how do I let the user know that we already found a user that exists in the database with that
When you
email
do a
address?
message that says you need that user exists.
Flash user exists, and then redirect them just back to this page, right? So redirect back to page, and then now a message is going to show up here and go, user already exists. At that point, or maybe even before then, it doesn't matter. You have a little link down here, or a little, something that says
Reset your password.
Reset your password. Maybe that's already there. So, you'll see it everywhere. Forgot your password? Reset. Also needs to point to some route. Users reset, right? And then that's going to generate a whole nother form that asks them for their email address, and then we'll issue however in the world you send a mail from Node, right? We'll send them an email, but knows that that particular user is wanting to reset their password, so that needs to get tracked in the database. And then the link needs to be associated with that particular user so that when they click on that link and visit some other page on your site from their email, you can look up that user somehow from the database based on the link that you sent them in the email and reset their password or give them the option to enter a new password, right?
I think there's a mistake in this little logic.
Okay.
And that's when, if the user exists and they're signing up, that means, to me, that person just needs to pick a new name.
Which is okay. Yes. So we have two routes from this point, right? This code is only redirecting them back to the page. Now the user is deciding what to do. In one case, the user may decide to reset their password.
They're on the sign-up page.
That's right. So in another case, they might just give a new email address because they know they gave a bad one and hit submit, right?
I've tried to sign up for a site only to find out I've already signed up for it before.
True,
saying.
but it's still they don't know that.
No, so this is not an either or.
Okay.
We have to account for both of those possibilities, right? So it's just that this bit of code here will only be responsible. We try to isolate what each of our functions does. This bit of code should only go, this user exists. Let them know that that email address is already in the database. Then they can figure out what they want to do.
So this is essentially if else.
If this is just if. This is a bunch of if else. That's right. So right, this is if. This is an else if. And so I flash back, and so we've accounted for the possibility of them having forgotten their password. Let's asterisk that because that's a whole bit of other detail. Let's assume instead that they actually got their email address right. Else, or they entered a new one. Now what do I need to do? So now this user does want to sign up. There was no error. The user doesn't exist. So what do I do now?
In the database.
Yeah, let me just say it.
So we add them to the database.
Add to database. Let's put that in quotes. What does that mean?
That now is on the list of authenticated users
Okay.
who cannot be duplicated.
So I'm going to go. I need to create some kind of new user. Mongoose provides the new with my user object, which I still haven't created yet. So I still need to create some kind of user object, make a schema for it, associate it with a collection in my database, right? And then I'm going to go what? Okay, user.email equals, right? User.password equals user.save.
You need to encrypt the password.
I need to encrypt the password. I just put a plain text password into the database. So now if anybody gets access to my database or somehow finds some kind of bug in my website, the password is plain text. So before I do this, I can say, yes, user.email equals, user.password equals some kind of encryption. And my handwriting is falling apart here, but we get it, right? Some kind of encryption. Okay, now we need to implement an encryption algorithm. That sucks. We don't really want to do that, right? In fact, never do that. Never implement your own encryption. Like Waylon laughing over there. The reason is you'll screw it up. The only people who should ever implement encryption are cryptographs, like cryptography experts, mathematicians with like 20 years of education in this. Use their algorithms and use the libraries that implement their algorithms and give you access to them. Fortunately, we have one. It's called bcrypt, which implements or part of the blowfish algorithm, and it's really easy to use and know. But yes, so we need to encrypt our algorithm, asterisk that. Let's asterisk our user. That involves some modeling as well. Now we're ready to save. So we save our user. There's an error, and the user object, if it works. The usual thing, we check if there's an error. There's an error. We can either render the 500 page, or we could send them back to sign up and go, man, we're really sorry. Try again in a minute, right? You don't want to just sort of kick them away from your site. But if it succeeded, now we have a user object. We've added them to our database. What happens next?
Then they,
Send them that verification.
Yes.
Okay, so now we need to send them a verification email. That's assuming that we're doing verification. So we'll start that verification, send verification email, but good. We're not going to implement that here, but yes. And then now what?
Now
So I'm still in my code here. The user's like still waiting to get some page back.
so you have to redirect.
Where do you want them to go?
Now the index page.
Index page, home page. I don't
Blog
know.
post.
I mean, yeah. Where? I mean, you choose, right?
On
Maybe
the site.
you have a profile page for the user. You send them to the profile
Did we decide
page.
if they're able to make posts or just make comments?
So we have not decided that yet.
Alright.
So that's good though. So let's. But we want to redirect them. Yeah.
So something to keep in mind is like if they went to a page that required authentication,
Right.
are you storing that, and then when they sign in, you redirect them to that?
That's tough,
Yeah.
right? So what if they go to try to create a post? It went, oh, you're not logged in, please log in. Takes them to this login page or the sign up page or whatever. They sign up, and then it redirects them to the home page instead of back to the comment or post that they wanted to comment on. Damn, that's not what they wanted to do. Now you just created an awful user experience for your user. So do you need to track where they had previously come from? But then if you're doing that, that has to be from the page that initially sent them to this, yeah? And so that's somewhere else. That got stored somewhere. And so maybe you page that they were previously at. Send them to that page, and if not, redirect them back to home or post or profile or wherever, right? So there's even more logic down here that you have to take care of. And we don't even know how to do that at this point. How in the world do you know what page they just came from? We talked about how HTTP requests are independent of one another. He has no idea that request A just happened. Yeah, this request has no idea that they came from some other page, unless I've encoded that in my URL somehow, or set a cookie.
Yeah.
And we're going to learn more about that in our Wednesday lesson. Point is,
It's a lot of stuff.
this is a lot of stuff, right? And this is just so a person can sign in. And we've got like 5 asterisks here. Yeah? This is hard. So it's not even necessarily that it's hard. It requires, again, this like attention to detail, this like ability to think very specifically about everything that might happen when a person interacts with your site. What's that?
Tedious.
It's not tedious. I actually kind of like this stuff. It's a very challenging problem to solve, right?
It's almost like more of a thoroughness.
There's a thoroughness.
It's like risk management. You're like make trees. What's going to happen?
Lots of
here?
it's really ultimately what this is a hell of a lot of trees. And so we didn't talk about this at all in this class, but you'll see stuff like UML diagrams, or I guess that's more for classes. But there's decision diagrams where you trace out everything that a person can do at some point in a system, and at what point they have to make decisions, and then you branch off for each of those decisions based on what it is, and take them to the next place in your system, and then figure out what their options are there. Yeah, it's like you're thinking through this thoroughly, with a lot of attention to detail. And if there's anywhere that you've got to do that, it is dealing with users, right? Because this is important. I mean, this is like this. Don't screw this up, basically. Yeah. I used to, when I had my just even my desktop application, people requested encryption. I was like, oh yeah, sure, I'll add encryption. Like actually, so it's a journaling application. People were like sticking their life's worth of journaling entries into this thing, and were wanting to encrypt it, understandably enough. And so I go and implement encryption, having no idea what I'm doing. And then I would get emails from people who were like, I forgot my password. I'm like, as far as I can tell, you're screwed. I can't decrypt the journal, your whole life's journal that you just put into my program. There's no way. And so, in future versions, because it's a one-way encryption, I disabled it. I was like, screw this. I can't I can't take responsibility for completely making inaccessible a person's like hundreds or thousands of hours of using my program. So it's like it's a nervous like responsibility, thing that is very touchy and a very sensitive topic. Yeah, I mean we hear about data leaks all the time, right? We want best practices. Like, what is the right way to do this? Can we learn from people who are already doing it? Can we use algorithms that people are already using, and so on? And the answer to that is yes. Like I said, there are libraries that we are going to use to make this happen, and there are some really great references. I saw one of our gentlemen pulling that up just a second ago. It's this form-based authentication link, and so this is from the web page. This is a Stack Overflow post where this guy is like, how the hell do I do user authentication? What's the right way to do this? Things that I need to think about. And these guys are like, here, consider this. And the answer to that is yeah. Like, yeah, this is all the stuff that you have to think about. This is all the stuff that you have to worry. And so I hope I hope you get the sense of this kind of exercise and just like how much more is involved, right? We are going to implement an incomplete version of basic user signup, basic user authentication, and basic user tracking. The way our system is going to work, we're going to keep it as simple as possible, and then in future versions you could build off that. We will allow anybody to sign in. If you are signed in, you may create comments. Right? If you are not signed in, you can view posts, you can view comments, but you can't make changes to anything. You can't create, you can't edit, you can't delete. But if you're signed in, you can create comments, you can edit your own comments, and you can delete your own comments. But you can't edit or delete other people's comments. So this is like the specifications we're going to set up for our application. Me deciding arbitrarily almost. If you are an administrator, and how do we know you're an administrator? If you are an administrator, you will be able to do anything. So you'll be able to create posts, you'll be able to edit posts, anybody's posts, but since you're the administrator, you're the only one who can create them. You'll be able to delete posts, and then you'll be able to create, edit, and delete any comments. You don't like somebody's comments, delete it, right? In some applications like WordPress, there's an additional layer where somebody submits a comment and it goes to approval for the administrator, and then the administrators approve it. Future versions. Yeah, it's more complex. Simplest that we can do is admins can do anything. Users that are signed in can create comments, and everybody else can just look. So ultimately, what we are controlling, I'll just pull this up on the
So
page.
users can just create comments. Users cannot create posts.
That's right. That's how we're going to set it up anyway. And there will be an administrator flag associated with our user model, which we haven't specified here, that will track whether a user is an administrator or not. When they sign up, by default, they will not be an administrator. We can manually go into the database and turn them into an administrator by setting that flag to true, right? So, right? And this is a little tiny piece of it, right? So, ultimately, what we are controlling access to is data, right? We have a database somewhere. It's full of data. We are implementing access controls to that data. How do we implement those access controls? We're going to do it through users. But then specifically, nobody goes directly to the database. People access the database through our web application, right? And that means, even with more detail, that they're going to specific pages in our web application, to specific routes, right? And so we need to set up access controls for particular routes in our application. Not just all of the routes. I want anybody to be able to view posts, but I only want to let some people create them. And so for that route there, the get post creation form, and then the post to the post creation process, that needs to be restricted to an administrator. And then again, we know who a person is by the fact that they've signed in and that they've flagged as an administrator. But now, how do I know that the person who is signed in at all, that they're signed in when they visit that page, and that they are specifically an administrator when they visit that page, right? And we haven't learned how to do that. We can do all of the other stuff. We can set up users, we can model users, we can create these pages for signing in and signing up, but we still have no way of tracking a person once they're signed in. So I signed in. My page says, congratulations, I just verified you. You're signed in. I checked your password, it's good. Now they go to create a post. My create post page has no idea that that person just signed in, right? HTTP requests, again, are stateless. They're completely distinct from one another. So we kind of touched on this when we talked about flash messages. We need to use cookies. A cookie is a piece of information that we will send back to the browser, and then the browser will send it with every single request it makes to our page. So when they sign in, we're going to set a cookie. The cookie is probably going to somehow track their user ID, their email address or ID in the database or whatever. And then when the browser visits another page, it's going to send that information with it. Then inside the route for that page, let's say to create a new post, we can pull out that cookie. And we can see that their ID is there. And then we can go and check that ID in the database. Is that person an administrator? Because now we're going to get that user information back, right? And then that all together is called session management. So we're tracking a user's session on our application. It's the combination of storing information in a database and using cookies. Waylon is going to talk more about this on Wednesday. And once we've done that, we have all the pieces that we need to implement access control, right? So today, after doing this brainstorming, we're going to scaffold user management. We're going to create the model. We're going to create the sign up and the login page. We're going to actually implement sign up and login, but without the session tracking. So we're just sort of like getting our feet wet. Then Waylon will give his talk, and we're going to implement the rest of it, this tracking and access control, using this passport module that will help us a lot, so that we have to write that stuff ourselves. So. Any questions about that? Let's take 5-minute break. So get up, walk around, move your legs, and then we'll come back and figure out how to do some of this stuff.
That's all.
So Aaron, they've got food and snacks and drinks and stuff. So.
Oh, sure, no problem.
I have no idea. I didn't ask. Oh, was there?
Yeah.
If it said that you can eat the cookies, then have a cookie. I'm not in control.
I can have options too.
You should have told me. I would have made something.
Made a cookie?
I can make anything you want as long as it's sweet.
Right.
How's it going? Going for another hour? Thank you for having me.
Yeah, no, you bet. So, yeah. I'm Phil, by the way. Too. Yeah, it's cool. So, I think most of the Tailwind staff is already left. But if they show up again and you're around, I'll introduce you. So they're the people who are working in the office space. So. Cool.
Thank you.
Mm-hmm.
Yeah, the ball and then it's alcohol. I saw something. Not very strong alcohol, but I mean.
You like math or just like computers?
Oh, I love
They let me recruit you then.
Yeah.
For my school.
I know take five, but that's not the original take.
Have you heard of Oklahoma School of Science and Math?
Yeah, the solo part.
The Oklahoma School of Science and Math. It's just down the street here. Like, we do a middle school math contest.
Really?
I'm gonna email you.
I'm not a brilliant jazz pianist.
And I will email you. It's just for 11 or 12. You don't have to wait.
Yeah, awesome. Yeah. So then you're. I mean, it's technical. Like knowing, like when I'm in a computer, here's like I have a sense for that sound, but I don't have a sense for it. Like I can just jump to that and right. Yeah.
Email address of one of the computer science professors. So if you ever have to touch you can always just tell her you know me.
Okay.
And she's
You know, she's like,
This was like
yeah. I've got keyboards too. Like I have like real handlebar keyboards that they use. Oh yeah, I love that stuff. Because you can pull out. I mean, you can pull organs out of the section. They're gorgeous things. Yeah, like whenever you draw it, submit it on play drum. I couldn't play drum also. Yeah.
So yeah, it's gonna be better.
Or you can call it.
We did when I was living in California. We did an open mic night with friends of mine. One on proper bass, like wooden, like stand up bass. And I was on the piano when we did take five. And the bassist, we all like took a solo. It was just awesome. Like bass solo. It's like because normally the bass is in the background, you know, doing the thing. And we're like, no, I'll take over the bass line. All right. And he just rocks. So he was just like all over the space, just killing it. I was like, man, that's so cool. Sometimes fun.
Never sugar rush.
Where'd you get popped out of his head? So,
Yeah.
Someone brought cookies. Who's brought those?
there's this girl here earlier.
Those cookies for us?
Yes.
Apparently. So,
Brownies?
if you're on the internet watching this, you should go get some cookies because that's what we're doing.
Brownies.
Brownies. Brownies is what I had.
Lemon bars? Wow.
All right, grab anything else that you want. Let's bring it back together. We still got a lot to cover. Right, so I made this stuff available on the site again. I'm gonna suggest once more that as we move the material, don't worry about keeping up with the coding in the HTML. It's all here. Everything that I'm putting on the screen is available from this document, and that way I can just like copy paste HTML and not have to worry about getting it typed out and moving along at the same pace. So this is a sort of the kinds of questions, just to reiterate, that we need to be thinking about. So users and the access that we want to give them. What kind of routes do we need? So it's stuff that we've already considered. Where should links appear, right? So we talked a little bit about that. So to the new pages. What does the sign-up process look like? How do we validate email addresses and passwords? So that did not occur here. So we forgot that step. If we didn't find a user, we need to check if that's a valid email address. Is it a blah@blah.com or blah email address, right? I used to get poo@bar.cux. So is it? And then the verification process is a second step. We might want to do some kind of password validation as well. Is it at least 6 characters? Does it have non-alphanumeric symbols in it? Whatever. So typically, you implement client-side validation in addition to server-side validation. And what I mean is there'll be something in the browser that will check to see that information is valid before sent. But you can always bypass client-side validation by disabling JavaScript, or just going straight to the post. So we also need to verify on the server and spit them back to the page, right? So we have to verify in 2 places, or validate, in 2 places. What do we do with the users who've forgotten their password? How do we let users change their passwords? So do we need a profiles page for that kind of stuff? What does our model look like? We've kind of talked about that. We know that we need to track email addresses, passwords, and the fact that they're an administrator or not. That's going to be our simple model for this. How do we securely store passwords in the database and ensure that passwords are communicated securely from the browser to the server? So right now we're saying let's encrypt the password in the database. Good. What we're not doing is encrypting the traffic between their computer and our web server. And so anybody who's in between them on the internet, between them and us on the internet, and that could be anything from a person on a Wi-Fi network to the NSA, can pick up on that password now that it's in plain text, right? That's probably not a good idea. So typically you implement HTTPS, or secure socket layers, through HTTP. And then it will encrypt all communication between their browser and your server and verify that you're actually the server they think they're talking to. Yeah. Maybe. I don't know. So, but anybody who's listening in between, right? We want to make it as hard for them as possible. So we want to encrypt traffic both between the browser and the server, and we want to encrypt traffic on the database. And if we have our database on a different server than our web server, which is common in like full setups, then we probably want to encrypt traffic between our web server and the database server, so that you have like encryption all the way through. Yeah. And you might think, man, this is just a stupid blogging site. Why do I need to encrypt traffic? They're just giving me a password. Because people are stupid and use the same password for many sites. If you do that, I'm sorry, I just called you stupid. Change your passwords. So.
Damn it.
I
don't mean to be so rude or direct.
Any kind of like, I don't know, privacy standards if you're capturing like blogging?
As far as I know, there is no regulations, like government regulations. If you're doing healthcare stuff, social security numbers, but I know for healthcare for sure, you have to follow HIPAA requirements. They audit, and that stuff is no joke. So yeah, compliance is no joke. So, but that is hard. But we're not. Yeah, we're not ready for that. So.
Website.
What's that?
What kind of website?
Healthcare. Anything that's dealing with patient information. And then some other ones that we've talked about. So. Okay, so let's see what this looks like. First thing we want to do is model our user. We know we're dealing with users. We're going to create a Mongoose schema like we've been doing before. We're going to associate it with a collection in our database, and we're going to make that available to the rest of our application. So this should look like nothing strange, right? I'm going to make a models user.js file. Schema is very straightforward. Right now, all we're tracking is email, password, and whether they're an administrator. We are using this dictionary, or the JavaScript object, to have more than just the type of that data. So we can say string, email requires true. We're going to trim it in case they have extra white space on the left or the front and the end. And then unique is true. So that way, even if we screw up on our code checking to see if that email address is already true or is there or not, Mongoose will check for us. Yeah, so that's a nice extra layer. Password, string, we're requiring it. The administrator is a Boolean. We're going to default that to false, right? So nobody's an administrator by default. And so I can just, create this file. I'm in the template that we've been using from before. I need to have a models user.js. So I'm going to touch models user.js to create it from the command line. There it is. And then since I've already got this on my site, I'm just going to copy paste this in there. And that's good enough. Yeah. What we're not doing with this schema is encrypting their password. So we need to implement that. Like I say, we're never going to store plain text passwords in our database. But encrypting a password is not actually as straightforward as you might think it should be. So we could use an encryption algorithm, and we can encrypt a person's password. So let's say I'm using a basic encryption algorithm like MD5 or whatever, and I take their password, I encrypt it, and I stick it in the database. So they gave me their password from the web form. I encrypt, so I get the encrypted password. And then I stick that in the database when they sign up. And now they're going to come and authenticate, right? They're going to log in. So this is sign up. This is login. And they're going to give me their password again. Their encrypted password is in the database. I have their plain text password. How am I going to compare these two?
Encrypted plain text password.
Again, that's right. So this is a one-way encryption. I can go in this direction, but I cannot go in the other direction. I cannot go from encrypted password in the database to plain text password. What I do is I encrypt the password that they gave me again. I make sure that I use an equivalent protocol for the encryption, so I'm encrypting it the same way. I'm guaranteed to get the same encrypted version. Guaranteed. That is a specification of the algorithm. And then I can compare that against what is in the database. Right? That's pretty good. The password that they gave me when they signed up is password, all lowercase. Or what is it in what's the in the Galaxy Spaceballs? Was it like 1, 2, 3, 4, 5 or something like that?
Yeah.
Right. Right?
That's the password.
5, 4, 3, 2, 1. Yeah, that's the password of my luggage. Like, what kind of idiot has a password like that? So the password they gave me is password. Somebody's trying to break into this user's account because there's sensitive information in there, and that person, just like every hacker you've seen on every web page or television show or whatever, is like, I'm just going to figure out their password. It's like, what was your mother's maiden name? Things like that. Sure. They guess password. This is a bad user. Guesses password for this person. I encrypt password. I get their encrypted password. Check it against the database, and it's correct. I just authenticated somebody who isn't the person they're saying they are. How do I stop that from happening?
Change your password.
So it's not just change your password, because now you might use a different password, but there's something known as a brute force attack where you have a list of words, like every word in the English language. And if your website is poorly designed to prevent brute force attacks, they can just try to submit every single password and check it against the encrypted version. And you might think, oh, they're not going to get through my web page. I have a process that prevents that. Except for somehow they got access to your database and downloaded it. So now they're just going to try it against the database directly. So what can we do? Yeah.
We can track their session through the IP address, and if it's another IP address, then we can do verification.
That's maybe only in the most strenuous circumstances, because people will almost always have different IP addresses. Even when you log in from your home, like your cable company or telephone company will just change your IP address. So that's maybe too strict. What we can do is hashing is what this is called, encrypting, also known as hashing. We can salt the password. It's a technical term. I don't know why it's called salt. Salting a password means that we add additional random characters to the text. So when they sign in or they sign up and they give me their password, I don't just encrypt their password. There's another process here where I salt it. I add a bunch of additional text to it, random string of text. AB $, caret, exclamation point, 57, capital FGD, or whatever. And I append that to their password, and then I encrypt that whole string, right? So now the person is going to guess their password, and there's an assault associated with it. But they don't know what the salt is. Unless they're going through my site and I'm using the same salt. That could be a little bit of a problem. Because I'm just appending the exact same bit of text, and now I'm resalting it again. So salting is an additional layer of security, maybe in case they get their hands on the database itself. But they're still, I mean, my process is always still going to salt it. And it's still going to be able to guess the password. So, yeah. So where's the salt getting stored? Right? So there's a couple of places that the salt can go. The algorithm that we're going to use is going to solve this for us as far as I understand it. And I might understand it incorrectly. If we put the salt like hard-coded into our application, we're using one salt every time. And maybe they can get access to that. But we can store the salt in the database, and we can change the salt for every single user that signs up. We can randomly generate a new string of characters, attach that to the password, and then store the salt and the password in the and the encrypted password. But somehow there's this weird combination of the salt and the encrypted password. All that gets stored in the database. And then when a user tries to sign in, this algorithm is going to figure out what the salt is from the database, combine it with the plain text password that they gave us, encrypt it all, and then check and see if it matches what it actually has in the database for the whole thing. So it's a much more complex process, partly answering where does the salt go. Exactly how it works is still a bit of a mystery to me. I don't understand cryptography. I don't pretend to. But this is the standard practice for securing a user's password. We generate random character of text associated with the password they give us, stick that all together, encrypt it, and store everything in the database. I got two hands. Yeah?
So if the person knows a plain text password, why wouldn't the salt just inherently or automatically be affiliated with it? And maybe this is beyond the scope of, well, this is...
But the salt is different for each user.
Salt's different every single time, randomly, not associated with the text.
But just for that user, just for that once. Each user has a different
salt. That's right. And it doesn't depend on their password.
Is a user, so how are we determining the user? Is it based on the person who has a password, or is it the computer? I mean, if the person has a password, what is a user? The user is the person with the password, no?
Yes, right.
So if I can guess the password, then wouldn't the salt follow?
If you can guess somehow, that's like there's some way that the salt works with what's stored in the database, so that just knowing the password or just like randomly guessing the password is not good enough, right? Because of that extra string of characters that's associated.
But what's the difference? I mean, if someone knows the password, what is the...
Well, if they know the password, it doesn't matter. They know the password. So it's broken. Like if you know, I mean, obviously, right? So if you know the user's password, nothing that you do is going to work.
The salt just protects the password in the database, right?
Right, I think so.
I mean, it's not like...
No. Although, yeah, my one might know better. This is stuff I find super complex.
That means person goes like, results for like someone just trying to guess, right?
Yeah, just random guessing.
Because there's different levels of password. You can have like a 10-character, an 8-character, and the salt changes it up. So if the hacker or whoever, they have no idea what sort of encryption method's being used, how long the password is,
right,
or anything.
If they got access to the database and they now try to brute force your password, yeah, they're almost never going to guess password plus 20 other characters that are completely random.
I see. So the salt is going to kick in once the database detects that, oh, there's someone who's entering and a certain number of has attempted to...
No, that would be separate. So that would be separate.
Because like what you're talking about is if somebody was entering the password in on the web page, then the salt doesn't protect against that. And
Yeah.
if they know the password, they're going to be able to log in.
That's right. Mostly it's protection against the database.
Yeah. Like if they got a backup of the database and they were trying to find
Exactly.
out what your password is based on the encrypted entry in the database, they couldn't.
That's right.
The salt.
That's right. So that's right. So if they know the password, none of this is effective. Yeah, unless you do some more strict like IP access or something. So. Brent, you had your question raised. If we can do it for a second.
I think that's fair.
So I mean, partly so I mean, I know I'm not doing the best job that's possible to explain this. Honestly, I'm not qualified to explain this. I don't know how cryptography works. I really don't. Myra's got his hand up over there.
You know, like literally the first paragraph on Wikipedia says exactly what you've been saying. It's protected from dictionary attacks.
Dictionary attacks against the database directly, right? Yeah. So. And it's good to, and we change the salt every time so that in case they get their hands on one salt, they don't have their hands on every salt. If they get their hands on one salt, then they can just try the database attack again. They can just take that word, every word, 100,000 in the English language, combine it with the one salt, and then attack the database dictionary or the database password. But if it's a different salt for every person, they're never going to figure that out. So good. So what we're saying is this protects against somebody who gets a hold of your database and can see the encrypted passwords in your database. It does not protect against somebody trying to access your site with like multiple passwords. Like they're going to send 100 passwords to your site, right?
They can still do that for one person. They just can't do it for everybody.
Can't do it for everybody. And you'll add security measures because you've hired a professional security guy to figure out this stuff for you, or some operations dude who goes, no, we're going to implement a system so that if somebody tries to do this web page 3 times in a row very fast from the same IP address, or they try the same person's account 3 times. So maybe in our model, we need to track how many login attempts have been occurred. And if it's more than 3, we go, hey, something's wrong with your account. We just locked you out.
Like your bank account. Like
your bank account will, right? Yeah, sure. So that's how you would prevent it against a direct attack to the site. So I didn't even think about that until we started doing this lecture, right? Even more complex stuff to think about. So, knowing that this is our strategy, the strategy here is that we're going to salt this password. How do we do that? We're going to use this bcrypt module to do it for us. And so it's bcrypt. We can install it with npm. If it does not install on your computer, use the bcrypt node. So there's a problem with compilation of the bcrypt on some computers. Bcrypt node solves that, but provides the same JavaScript interface. But for me, I can just npm install bcrypt and save it. So that's what I'm going to do. Npm install bcrypt, save. I'm going to write it to my package.json file after downloading it, right? And you can see it does a little bit more. I think it's actually compiling some stuff here. But if I cat package.json, bcrypt is now in there. Fantastic. So what I want to do, I'm going to use this library inside of my user model, right? So I need to require it up in here somewhere. Var bcrypt equals require bcrypt. And bcrypt is going to provide hashing, salting, and validation checks for me. But I want to write an interface to that. So we're going to learn something here that we haven't done before. I'm going to add some methods to my user object, specifically an instance of a user. So we know that like if I create a new user somewhere in my application, and I'll just do it in a blank page, I can do stuff like var user equals new user, and I get an instance of a user back, and then I can say user.email equals request.body.email, user.password equals request.body.password, except for somehow we're encrypting all of this stuff. We don't know how yet. Okay. I can add methods, my own functions, just like we've seen with other JavaScript objects, to this user instance. So I could have a method like user hash password, and it will hash the password for me. Or I could have a method like user is valid password, and it will check if the password is valid for me. How do I do that? Mongoose provides a way to do that. We write some additional code on our schema in here to add our own methods, and then those methods become available anytime we have an instance of a user. And again, we didn't discuss the difference between an instance of a user and this like big user in too great detail, which is too bad. That's maybe an important part of the JavaScript that we sort of blew through. But we've been distinguishing between the user like class with a capital letter and an instance of a user, a specific actual user who has an email address and a password and so on. This is like user in the abstract. This is like actual user with a lowercase letter. Yeah, that's how we distinguish between those. So I can add methods to my user schema through this schema object using Mongoose. I pull this from the Mongoose documentation. This is how I know how to do this. I can say schema.methods dot, and then whatever I want to call this function, this method. And then I say equals, and this is all should be familiar. I assign it to a function, right? Function password, and then in here I can call bcrypt.hash synchronous, not asynchronous, so it will complete, and then return the password plus some kind of salt, right? And then later on I can add another method, isValidPassword, that takes a plain text password and uses bcrypt to compare it against the password in the database, which will be this .password at that point, the particular user's password, because the only thing that ever gets in the database is the encrypted version. And this will refer to that actual user as so far as its data has been pulled from the database. And so I can add these methods to my schema. I'm going to copy and paste them here. And now these are available. I have a user.generateHash, like that, and I could give it request.body.password. And then I would assign the whole result of that to the password, right? And then later, I can say user.isValidPassword with request.body.password, and that will return true if I have a valid password or not. All the while keeping everything encrypted in the database, right? So that's what our user model is looking like. For what we want to accomplish, it can be that simple. You know, we don't need anything else. Next, and again, a word on encryption, don't do it yourself. Same thing I was saying earlier. So let's actually sign up a user. So it's good we've already discussed the routes that we need. We know we need a get route for the form. And we know we need a put or a post route for actually creating the user. I went with users sign up, and I'm using the fact that Express already sets up a user route for me. Like when we created this application, Express put that line of code in there, right? So I already have a routes users file. That already exists. It's right here, users, routes, so routes users. It's basically blank. There's nothing in here except for users / but it doesn't do anything. But we can add our methods to this. Yeah. You could really do whatever you want with routes. You could have a plain sign up instead of user sign up, whatever you want. I'm just going to use the material that we've already been given. I need 2 routes, so let's delete the one that's there because I'm not going to use it. I need a router.get sign up, right? That takes a request and a response handler, and we'll do something. And then I need a router.post to the same page, sign up. And again, this is prefaced by users, right? So. And we know that from this line of code where we say users, and then down here where we say app.use, we're prefacing it with users and then pointing it at that user's routing. Say app.post sign up and request response. I'm going to sign up, right? For my get, I'm just going to render some HTML. So I can say response.render. And I'm going to create some EJS file somewhere in my views. Let's put it in the users folder, signup.ejs. I should really pay for Sublime. So now we need to create that form, right? It's going to go in my views folder. We're going to put it in another folder in there called users. And then I need to touch this signup.ejs file. So I switch into my console. I make dir views users, and then I touch views users signup.ejs. Right? So now I've got a users folder and a signup.ejs file. And this is just HTML plus some embedded JavaScript. What's going to go in here? Let's copy and paste what I've got in posts already, because that's all my bootstrap styling, and plus my nice layout. I need to change, again, this is all just my extra bootstrappy stuff that I've got. I'm going to change my template code here, change this link, get rid of that template code. That's where my form is going to go. We still want to support a flash message, but it won't be for success. It'll be for danger when they enter an email address that's already in use, or when they provide maybe some other kind of bad input, right? So I'll do success, switch that to danger. Danger, danger. We know to use that from previous lessons, but also because Twitter Bootstrap provides this alert danger class. So we can flash a message.danger and know that it should go in that, right? So my sign up form, already got that in there, is really straightforward HTML. It's just everything that we've talked about, nothing special. The things that we note, the things that are important to note here, are that our action will point to the user's sign-up page. That's the route that we just established for the post. That our method is post, and then when we have forms for emails and passwords, we name them correctly. Right? Name is email, name is password, and then a submit button. So this is nothing special. So I'm just going to copy paste that right in. That's really straightforward. Clean it up a bit. Okay. And let's test that. So we've got some HTML, we've set up some routes. Let's make sure that I can get to this web page. I'll start up my application. I haven't started up my database, so I need to go MongoDB, dbpath db. Excuse me, MongoD, dbpath db. Start up my database. Kill that. Start up my server. Go to my web page. So localhost 3000, right? I should see my posts that I've got in there. Fantastic. Now I should have a user's sign-up page. There we go. Right? And this is just really that basic Bootstraps forms. But when I create, or when I hit that sign-up button, I'm going to post to this route, and right now that route's not doing anything. So if I do that, my web page is just going to hang. But we've got the basics, right? We now have a web page for signing up. We now have the user model for signing up. Now we need to implement this actual code. And this is everything that we've talked about right here. We're literally just going to do everything that we've just talked about. Mostly everything. We're not going to send out emails and stuff, but well, actually, we're not going to validate the password either, so asterisk all of that. The plan, though, to look at our code on the side here. Check if a user with that email address is already in the database. If so, let them know the email is in use. Maybe provide a way to reset the password. We talked about that. If the email is not in use, create a new user. Use the request.body for the email address, getting the email address and the password. Use our generate hash function to hash that password with a random salt, and then save it. And if that's successful, we'll flash a message that the user is logged in and redirect them back to some page. In our case, we're just going to send them to the post page. Yeah. And with a flash message for success. And we already know that that will show up in our application because earlier in our posts view for the index, we added code for flashing a success message when we created a post. We're just going to reuse that. Right? Doesn't matter what the message is, we can still stick it in message.success. So this code is quite a bit more here. I'm going to copy paste it and then we'll just make sure that we understand all of these steps. But it's exactly what we just talked about. Oop, I've already got that bit in there. Mongoose provides a find one method on this abstract user object. We give it the email from the body, takes a function with an error callback and the user if it finds one. If we get an error, render 500 or do whatever. If we don't get an error but the user comes back, we say danger, email address is already in use, and redirect them back to that page. Right? Otherwise, let's create a new user, set their email, assign their password, but now using our user.generate hash function based on their password from the body. Save the user, which takes an error for its callback. Check if there's an error. If there is, render 500. If there's not, flash success. Thank you for signing up. Send them back to their profile page or wherever. We'll go just to posts. Does that logic make sense? This is the actual implementation detail, so check it out on the page to see what it really looks like in JavaScript. But it is exactly the logic that we discussed here. Asterisks for validate the email address, validate the password, make sure it's enough, characters, and then maybe add a flag to the model. You can imagine our model having a verified flag that defaults to false. And now in this sign up somewhere, we actually also fire off an email. Right? Let's make sure I didn't blow up my user model there. That all looks fine. Okay, so now I've got my route for handling the post. I've got my user model. I've got my web page. I should be able to go to that form, enter some information, hit submit, and a user will be added to my database. So let's see if that works. I'm restarting my server. On my web page, I'll refresh it. Everything looks good. I'll do phil@phildow.net with test for my password. Sign up. I go user is not defined. That's good. I meant to fix that, but it's okay to get an error. Let's see what's going on here. Reference error. User is not defined. Where? Object model.export, users, OK coders, documents, blah, 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 routes, users.js, line 9. So we just got a blow up. How do we solve this problem? Read the error message first. We know that somewhere there's this variable that I've got, user, that does not have a value. It's undefined. It's on line 9 of my users.js file. Okay, so I go to line 9 of my users.js. I sit right there. It's talking about user. I never defined what user is anywhere. Yeah. What is user? User is this thing that I export from my user model, just like big post and big comment are. So I can go var user equals require relative to the current folder, back up a directory because I'm inside of routes. I want to go up to the root directory of my application, go down into models, and get user.js, but I don't have to specify .js, right? And so I'm referring from this file to this file. Here. Make sense? And that's why that object is not defined. We didn't say what user was anywhere. Semicolon. Start my server. Let's see, got a syntax error somewhere. Can't find module, models, user. No, I made a mistake. Users. But I really want to call this user. Yeah, models is typically not plural. That's just a practice. So I'm going to close that. How am I going to fix that? I'm going to use the command line to move models users.js to models user.js. Move is also the command for renaming a file from the command line. There we go, user.js, that's what I want. Now that should work. I can restart my server. Right. Good when the problems are like expected. Not like some of the earlier ones that we had. Let's try this again. We'll go to sign up, give it an email address, test for the password. Boom. Signed up, logged in, redirected to posts. So what has happened? In my database, I'm going to connect to my Mongo database. I have my blog database. You can see the collections. I now have a users collection. Fantastic. We know that from the model, right? From our user model here, where we say, hey, this schema is associated with the users collection.
So this user just gets assigned that number 1 or the same thing.
Yeah.
Before. Well, we'll deal with that, I guess.
That we'll deal with that. That's right. So we may not even get to that Wednesday, but the trick would be to change that to whatever that object ID is. Yes, exactly. So I've got my users. I can go db.find, db.users.find, all my users. There it is. Me with a very nicely encrypted password that good luck anybody figuring out, even though it is just the word test. Yeah, with a random salt. So I could sign up another. In fact, let's do that. We can see that my email address is filled out, and I got default values for verified and false. I can go, you know what? Let's sign up another user. Use a different email address. Actually, let's use the same email address and see what happens. Good, we got our email address already in use here. I'm going to use a different email address, phil@test.com. I'm going to use the same password, test. I swear I give you the same password here. I swear it. Sign up. Great. Let's look at my database. Look at these passwords. Different. They start the same way. That identifies them as blowfish encrypted passwords, or however the algorithm is, but they're different otherwise, even though I use the same password. That is the effect of using a salt. Because I added a random string of characters to the word test in both cases, and so the final encrypted version is different for each one, right?
So does that actually make the encryption a little weaker, that it indicates what kind of encryption it is at the beginning of it?
I doubt it. I think it's a pretty strong algorithm, but I'm not an expert about that, so.
You can still break it. just for that one, it's tougher to do. It's tougher to do in mass. I mean, everything can be broken.
Yeah, but I think that's still pretty solid. I think particularly this algorithm is a pretty well established one. But again, I'm not an expert, so caveats on all of that. So, it's some kind of version of the Blowfish algorithm. I include links to it in the GitHub page. So, okay, this is all the logic that we've talked about. This is everything that we brainstormed. It's just how do we do it. Let's implement one more piece of this puzzle, and that will set us up for our final lesson where we actually start to track users who are signed in. Right now, I don't have a way to sign in. I need a way to sign in. Process is going to be very similar. I'm going to provide a web form that asks for their email and password. It's a two-step process. I get that form. I post to that same URL. Now I have a username. I'll find one to see if they're in the database, so the route will be almost the same as well. Only now, if I find the user, that's what I want, right? So then I'll check to see if their password is correct using this nice little isValidPassword method that I wrote. If it is, I sign them in. If it isn't, I redirect them back to that page and say your username or email addresses, or your email address or password is incorrect. And then probably you give them an option to reset their password or try again, right? So almost an identical process. Just slightly different here. In fact, a little bit less work here because we don't have to do this stuff. We're not going to create any user. So what do I need? I need two routes. So let's go ahead and define those. I'm going to do router.get, say login maybe, request response. And then same thing, router.post for login because that's where it's going to go. This guy is just going to render some kind of HTML in the response. It'll go my users.login. Yeah, that's what it's going to do. Do I have to say EJS? Nope. Get signup.EJS. I suppose I do. Although I bet you could figure it out if I didn't. Okay, so that means that in my users folder, in my views, I need a login.ejs. So I'm going to touch that. Touch views users login.ejs. Now have a views users login.ejs. It's going to look exactly the same as my sign-in form, or my sign-up form. So I'm just going to copy paste that. Maybe I could rename this to user sign-up. Literally same thing. Now it's going to be user login. It looks like I'm repeating myself. There we go, perfect. Only now, instead of posting to sign up, I post to login. Exact same thing otherwise, right? I don't need to do anything different. I need the same information. I need to check for errors very similarly and flash them if they come. So again, name is email, name is password. Just make sure we get those things right. I use Bootstrap for all the styling. Let's make sure that that shows up. Good. We might change that so that it's not highlighted. Maybe we just don't show anything, whatever. Now I need to actually do something when I post to this URL, this guy right here. Okay, make some space so this more towards the top of the page. So what do? Look at the code, and then I'm just going to copy paste it so we can see. This is where I actually authenticate the user. So here's the form, the routes that we just templated, handling the form input. I'm going to look for that user in the database using the same method user.findOne with the same email request.body.email, right? Function callback gets an error, and then the user instance if it was found. If I get an error, it's an error. Otherwise, if I don't find the user, so the user does not exist, that email address is not in the database, or the user's password is not valid, then I should redirect them back to the login page with email or password is incorrect. I shouldn't tell them which one. So as an extra layer of precaution, I just say one or the other is incorrect. Double check, leave it to the user, figure it out. Otherwise, I'm going to say, hey, guess what? You logged in, fantastic. Let's send you to the post page. Very straightforward. I think this is very simple, especially considering that logic that we have there. Login is much easier to handle. So I'm going to grab that code. Replace this with it. Start my server. Let's log in a user with the wrong password. Email or password is incorrect. Let's log in a user, and we might want to notice that I lost my email address. Sometimes they keep the same email address in there. You could redirect back with an email address and use the EJS, the template language, to embed that back into the form. I'll leave that as an exercise to you guys. So I put my email address, test is my password, flash that I've successfully logged in, redirect me to posts. Right? So that's not so bad. Let's do one more route here, and we're going to wrap it up. We're in pretty good shape, as much as we're moving through this pretty quickly. I'm going to add just a template for a logout route, so a user's logout. And all it's going to do at this point is say, great, you're logged out. Right? That's all it's going to do. There's a template for future work. So all I'm saying is, you logged out. So I could send them to, or I could go to just the, I have to restart my server. Or use, what's the tool MIWO for restarting the server automatically? Supervisor, sweet. Okay. So I can go to users, log out, and it's going to go, you logged out. None of that really has any meaning, though. All we have done so far is made it possible for users to sign up and for users to log in. But now if I go to another page like post, or I go to create a new post, even if I've signed in, we have no idea that I'm signed in right now. I have no idea. The website has no way of tracking that. It can authenticate, it can check against the database, but it's not tracking the fact that I have signed in. That is the next big step. That is what we are going to learn about on Wednesday. It's the final piece of this puzzle. It is our last lesson. Again, Waylon will talk about how that works sort of behind the scenes with cookies and sessions, and then we're going to see how to implement that using Passport, which is a node module that handles a lot of that behind the scenes work for us, because we don't want to write it ourselves. It's a lot of material, a lot to think about. Any questions? Sweet. I think this is tough. You guys are like, I'm looking out at you guys, and you're exhausted, right? So this is a lot of material. This is no joke. See if you can implement this. Yeah. So that's your basic homework assignment. Building off your templates or starting a new project. Go through this material again. It's all up here, right? So you didn't get a chance to read it the first time. Now you got a chance. Between now and Wednesday, just make sure you get the logic. More importantly than the specific JavaScript that we've written, that you understand the logic of why we're doing things this way. And I really would encourage you to check out this Stack Overflow form-based authentication, the definitive guide to that. Might look at Wikipedia's entry on access control, salting if you want more information about why that works or doesn't. And then this bcrypt module, how did I know how to use the bcrypt module? Well, because they provide documentation like all good libraries do. I can just click on that and they're like, here's how you do it. Like that. Like, fantastic. Right? So, all right, thanks guys. I know that's a tough lesson, but this is the real deal. So